Hi everyone. In this video we're going to be working with dividing polynomials by monomials. But before we do that, we first have to remember a few rules from algebra that we have to be good at in order for us to be successful in dividing polynomials by monomials. So the first thing we have to ask ourselves is what happens when you have a number in the numerator and a number in the denominator? So what happens when you have a number on top and on the bottom? Well, remember, in pre-algebra, they told us that when we have a 12 over a 6, for example, we're supposed to divide these two numbers together or simplify the fraction. So 12 divided by 6 is going to simply be 2. So every time that you have a number on top and a number on the bottom, you're just going to divide both numbers into each other. But when you have bases, for example, x to the 8 over x to the 4, we have to simplify it by doing what method? When you divide bases, what do you do to the exponents? You actually subtract the exponents. So in order to simplify this, you have to do 8 minus 4, which is simply going to be x to the 4. And then whenever you have a negative exponent, you're not allowed to have them, so you have to simplify it. So if there's a negative exponent in the numerator, this is simply going to go to the denominator. So this is going to become 1 over x to the 3. So every time that you have a negative exponent, it's going to go to your denominator if it's in the numerator. Okay? All right. Once you're ready for these rules, we're ready to begin. So what we're going to do is we first have to know what are the steps. So our steps are going to be, what are our rules? The first rule that you want to know when you're working with a polynomial compared to a monomial is we want to separate everything into different fractions. After you separate into different fractions, you're going to divide the coefficients, which are the numbers in the front, and then you're going to subtract the exponents. But remember, if you have a negative exponent, what's going to happen? It's going to go to the bottom. So these are the 3 rules that you have to be successful with in order to be good at solving these problems. Separate, divide the numbers in the front, and subtract the exponents. And if the exponents of the bases do not have similar bases, then just leave them where they're at. Okay, so are you ready? So in the first example, what we're going to see is they're going to tell us to simplify 9x squared minus 3x over 3x. Notice that this is a polynomial and this is a monomial. This is actually a binomial compared to a monomial. So the first step is we're going to simplify this by rewriting this as 9x squared over 3x. Step 1 is separating. So however many things I have on top, however many terms I have on top, that's the number of fractions I'm going to have. Now next, I'm going to do the steps. Divide the coefficients. 9 divided by 3 is simply going to be 3. And then you're going to subtract the exponents. But before you do that, remember the rule. Make every exponent that's missing a 1. So when you subtract it, 2 minus 1 is 1. So it's going to be simply x to the first or just x. Now in this case, you have 3 over 3. Remember, that cancels out. X over x also cancels out. So when everything cancels out, you have to be left with one number, which is a 1. And that would be my final answer. So divide numbers in the front and then subtract the exponents on the bases. Okay, next. Once you feel like you're getting the hang of this, definitely pause the video, try a problem, and see if you get it right by playing it. So in example 2, you're going to notice they want us to simplify that polynomial, which has 4 terms, by a monomial. So what we're going to do is we're going to do first step, which is separate. Now, as you're separating, it's going to sound tedious, but you just want to be careful. And whenever you don't have an exponent for a base, try to put a 1. Okay. So after you separate, you're going to divide all the coefficients, but the problem is, notice, there is no coefficient in the bottom. So that means that simply it's a 1. 10 divided by 1 is 10. So what you're going to do is you're just going to keep 10 as it is. And then when you subtract the exponents, x over 4 x3 is simply going to be what? X to the first. Now next, you're going to divide them. There's no number, so you're just going to put a 5. x3 over x3 cancels out, so you're simply going to be left with a 5. Afterwards, 2 divided by 1 is going to be 2. X squared over x3 is going to be x to the negative 1, which means what is this? Where is this going to go? It's going to go to the bottom. But we'll move it on the next term. On the next problem, you're going to have 5 divided by 1 is 5, but x over 3 doesn't have an x on the numerator, so what happens? That's going to stay simply where it's at because it doesn't have anything to combine with. So the only one that I have to move is this one because I can't have negative exponents. So when I rewrite this is what I have. 10x minus 5 minus 2 over x1. Notice that the only thing that's going to move is the x because the 2 doesn't have a negative exponent. So yes, it's negative, but the number is always going to stay in the numerator and the variable is going to go to the denominator. Now, do I need this 1? No, I do not. So we're going to go ahead and just erase this 1, so it's just x. And then the other one, the last term, just stays as 5 over x3, and that's my final answer. So same rules, separate, simplify, and when you have a negative exponent, bring it to the bottom. And if you have a base that cannot be combined with any other base, just simply leave it where it's at. Okay, so we have 2 more examples. So when we move on to example 3, you're gonna notice example 3 has not just 1 variable, but 2, and that's okay. You're gonna combine these and separate them just exactly how you would do if you're multiplying. Bases go with bases, numbers go with numbers. So if you're ready, pause the video, try it on your own, and then press play. So in this question, you have 3 terms on top. So I'm going to separate this to be 3 different individual fractions. But notice that this y doesn't have an exponent, so I'm going to put a 1. The bottom is perfect, 5x squared y cubed. On top, it's going to be 20x to the 1, y to the 3, over 5x squared y 3. And the last one's going to be 5y to the first, because it doesn't have an exponent, over 5x squared y3. Remember, it doesn't have an x in this, so it's kind of strange, but it's okay. So after you separate them, we're going to divide the coefficients. 10 divided by 5 is going to be 2. X squared over x squared cancel out, so make sure you cancel them out. Y1, y3 is technically y to negative 2. Next, you're going to do 20 divided by 5, which is 4. X1, x2, 1 minus 2 is negative 1. Y3's cancel out, so y's are gone. The next one, I have 5 divided by 5, which is 1. Technically, the x doesn't have anything combined with, so it's going to stay on the bottom. And then y1, y3 is technically y to negative 2. But I have 3 problems. I cannot have a negative exponent. So this negative exponent is going to come down. So this is going to become 2 over y squared. Remember, once you bring it down, the exponent will turn positive, and the 2 is going to remain on top because the 2 did not have a negative exponent. Next, the 4 stays in the numerator. The x drops down to just be x. And this one, the y comes down, but I still need something on top, so I'm going to leave that 1 on top. And that y2 is going to join that x squared that didn't have anything to combine with, and that's going to be your final answer. So in these problems, you have to be extremely careful with what you do because you have to work with the coefficients and work with each variable individually. X's go with x's, y's go with y's. If it doesn't have an x or a y to go with it, it just stays where it's at. Okay, and in our last example, example 4, you're gonna notice the same type of problem. But what I want you to do is try this one. Pause the video, and when you're ready, press play. So in this example, you're going to notice that you have 3 terms on top, 1, 2, and 3. What we want to do is we want to separate them. So we're going to separate them as 3 individual fractions. Now, be extremely careful when you're rewriting this because one simple mistake is going to change everything. And then once you have that, what we're going to do is we're going to go ahead and actually combine. So notice that none of the coefficients in the denominator have a number except 1. So all these numbers are going to stay. 6 divided by 1 is 6. X2, x4 is x to negative 2. Y's cancel. Then I'm left with 10. X to the 1. 5 minus 4 is 1. Y2, y3 is y to negative 1. 3, x1, y1. Now after you do that, our next step is we have to move negative exponents. So what we're going to do is we're going to move all the negative exponents to the denominator. This is going to come down, the y negative 1 is going to come down, everything remains the same. So the 6 is going to be in the numerator, x squared joins the denominator. In this case, 10x stays in the numerator because they're both positive exponents, but the y negative 1 comes to the denominator. As technically y1, but you don't need the y. And then 3xy is going to stay exactly where it's at because they all have positive exponents. So it's going to be just 3xy. And that is your final answer. So again, when it comes to working with these rules, you have to be careful in all of your steps. But the rules are always going to be simply as this. Separate into different fractions, divide the coefficients, and then subtract the exponents on similar bases. Every exponent that has a negative exponent after you subtract them will go to your denominator. So thank you all for watching. Best of luck, and I'll see you next time.